So welcome back, guys. Today we are going to discuss SPSC, Sin Public Service Commission Subject Specialist Paper of 2023. It's me, Munawar Ali, PhD scholar at Florida State University. So I have taken paper type B, and there are in total 50 questions. There are 2 marks for each correct question and negative 0.5 mark for each incorrect question. The exam was held on June 3rd, 2023. So I'll be making 5 different parts for this, and each part will contain 10 questions. So in this part 1, I am going to discuss 10 questions with you, the first 10 questions. So the first question was, we have a set A and a set B. So we have set A that contains elements A, B, and C, and set B that contains X, Y, and Z. And there is a function that takes A and sends it to Y, and it takes C, sends it to X. We have to select any one option of these. So it defines either a 1-1 function, onto function, 1-1 in onto, or it's not a function. So when we look at the definition of a function, it is that for each element in the domain set, it means A, there exists a unique Y in the codomain set such that Y is equal to f of x. So there are 2 things which are important here. One is, for all x in A, there is a unique Y in B. So these 2 things are really important when we are going to check that whether relation is a function or not. So when we see that, okay, A is mapped to something, C is mapped to something, but B is not mapped to anything in the other set. So we say that this is not a function. So the correct option is D. So second question is, it's very simple question. So some questions really ask you some sort of formulas or definitions. So you are supposed to keep something in your mind when you are going to attempt those questions. So this question says that if we have a polynomial with degree at least 1, then which of the following is true? So this is simply what we say division algorithm in the sense of polynomials. So the correct option for this one is A, because here the polynomial is P of x, which is divided by x minus r, and this Q of x is quotient. Then we add something to it, which is what we call remainder. So like seemingly this question is like simple. If you know the things, you can answer it. Otherwise, like it's very difficult to answer if you don't know, if you don't remember these things. So the next MCQ is, for 2 vectors A and B, which of the following is true? So the sum of A plus A and B is same as the sum of B and A. So this is simply commutative property of addition. This is commutative property of dot product. And in general, we know that the difference of 2 vectors is not same as if we swap the vectors and take their difference. But the length of these is always same. So keeping these all the 3 things, the correct option is D. So I'm going to remove highlight from these, and the correct option for this one is D. Similarly, moving to the next question, question 4 says commutative group is called. So it's very simple. If you have a group which has basic 3 or 4 properties, you have closure, you have associative, and you have identity element, and you have inverse of each element. with respect to the operation defined, then if the group is commutative with respect to the binary operation, then we call it abelian group. So we cannot select monoid, but because it's not a group, semigroup is not a group in general, and obviously the correct option is A. Moving to the next one, we have a group with this binary operation, whatever it is. So in this group, if we take each element in the set of the group, which satisfies this property, this is called commutative property. So we simply call it commutative group or abelian group. So the option correct is commutative group. So this is question 5. Correct option is option A. For the next question, it's related to abstract algebra. I'm not good at that one, but I'm trying to do this one. So we have R, which is an integral domain. Which of the following is not true? So you have to be careful about these words. Which of the following is true and which of the following is not true? So is this a commutative ring? And if it is integral domain, it has no zero divisors. And if that integral domain is finite, then it's a field. All these statements are correct. So if you take a ring, and within the ring, if there is no any zero divisor, we call that ring to be an integral domain. And what do you mean by zero divisor? So if we take two elements from some ring, and both of these elements are not itself zero, but their product is zero. So like in standard rings that we discuss, like ring of integers or real numbers, this thing is like nonsense. But when you go to, let's say, some other rings, let's say finite rings, Z6, then you will see that, okay, this thing happens. If you take this set, if you take Z5, then there is no any zero divisor in this one. In Z6, if you take 2 and if you take 3, these are not zero itself, but their product under modulo 6 is going to be 0 under modulo 6, not in general. So, and the first option is R is a commutative ring. So if it is an integral domain, can be a commutative ring. And if R is finite, in the case of, let's say, Z6, it's finite, then it's a field. Because in these finite integral domains, you can find out the inverses of each element easily. Because by the definition of inverse, it's not that, okay, inverse of 2 is 1 by 2. It can be 3. It can be something else, which gives you the product of unity. That's the inverse. But it's not a division ring. So for a division ring, there must be existence of inverses of each element, which is not true in the case of integral domain. So our correct option is D. So this is the option which is not true. So our correct option is D. So I'm not going to explain this question in detail because I'm not very good at that one, but you can further see that, okay, how the things work. So I'll give you maybe some tricks that, okay, how can you exclude the incorrect options? So next question is MCQ number 7. The thing is that this problem doesn't make sense to me, but okay, like the first thing that we have to see is what is n. If n is a natural number, then it is somehow good. We can deal with this question. So we have Cauchy's theorem that says that if f of z is analytic within n on some sort of simple closed curve, then integral of f of z over that closed curve is 0. So f of z analytic implies this. And there is converse of this theorem, what we call Morador's theorem, which says that if this integral is 0, then this function is analytic. We see that this is z power n, which is analytic if n is a natural number or something which is bigger than 0. So this is analytic function. If this is 0, then C must be a closed curve. It should be a simple enclosed curve. The thing is that the sufficient answer for this thing is at least closed curve. So option D is analytic curve. And what do you mean by analytic curve? That's a question. B is smooth curve. It's not necessarily to be a smooth curve, because you can take analytic functions and you can take their integral over some sort of a square. Still, it's going to be 0. So there's no issue with that. And simple curve should be there, but the sufficient thing is closed curve. So, but here the problem is n should be either, let's say, positive, and it can be, I think, 0, it works. There should not be a negative number. If n is -1, that's a really a problematic thing, because then it's not going to be 0. Okay. So the next thing is, if the correlation coefficient is 0, sorry. So if the correlation coefficient is 0, then the two regression lines are parallel, perpendicular, coincident, or none of these. So like this is some sort of question which is related to statistics, but let me give you something that might help you. So if we have some data, we are given some sort of data which is maybe random, maybe something else. Then we can find the regression of y against x or x against y. Then we have formulas for that. X is some sort of coefficient, which is axy plus bxy times y. And we can find y as a function of x, which is ayx plus byx times x. So this b is exactly what we call correlation coefficient. So this can be found again of x against y or y against x. So if this coefficient is 0, so simply you can see if this coefficient is 0, then x is, this number is some sort of constant, let's say c. And y is, let's say this one is c1 and this one is c2. So what can you tell about these two lines? So x is some sort of constant. The equation is, the line is always some sort of vertical line, because here there is some c1 value, and y c2 is some horizontal line. Here this is c2 value, and these lines are always perpendicular to each other. So the correct option for this one is B. If the correlation coefficient is 0, then the lines are perpendicular to each other. Okay, so next question is MCQ number 9. This says that 4 persons are chosen at random from group containing, so there are 3 men, 2 women, so man, women, and 4 children. 3 men, 2 women, and 4 children. The chance that 2 of them will be children is, so we have to select 4, but out of them 2 are children. So what we are doing, so children are 4. We have to select the chance that 2 of them will be children is, so we have 4 choose 2. So I have chosen 2 children, but I have to choose remaining 2 people as well. Now, what am I doing? I have different options now. So I'm choosing all of them to be male, or all of them to be women, or 4 choose 2 times 1 male and 1 female. So these are like the number of ways that I want, and the total number of ways is how many people are there. There are 3 plus 2, 5 plus 4, 9 people, and I'm going to choose 4 out of those. So this is my option. This is my answer, but I cannot see this option anywhere. So obviously it's going to be none of these. Yeah. Okay, so the next MCQ is MCQ number 10, which says that, okay, we are given a function. Is this function implicit? So implicit function is some sort of function which is written in this way. Even function, we know very well it is some sort of function. If you replace x by negative x, it is going to be same thing as f of x. And odd function is f of negative x is the whole function with a negative sign, and explicit function is something which is written in this way. So obviously this is some sort of explicit function. Okay, so this is MCQ number 10, and I'll be discussing rest of the MCQs in maybe next parts.